Dear students, in the last class we have discussed about the variable frequency control of induction motor drive, in which from up to the base speed we have to maintain the ratio of voltage upon frequency V by F ratio constant, and above the base speed we have to make the constant voltage and variable frequency mode. This is the block diagram representation of the variable frequency variable source scheme, in which this is the variable frequency variable source block, this is a delay block, this is induction motor, and this is flux control block. In this diagram, V star and F star, V star and F star are the signal which is provided to the variable frequency voltage variable source block. Flux control block. This is a flux control block. It produces a voltage command V star for VF VS block, and FR is the reference frequency. By controlling this FR, we can control the speed using this VF VS block. Control the speed of induction motor. A delay circuit is introduced below between F star and FR. We can here this is a delay circuit which is between F star and FR. This delay circuit is introduced so that even when FR is changed by large amount, F star will change only slowly, so that motor speed can track change in F star. So using this scheme, we can maintain and we can control the speed of induction motor, and up to the base speed the V star and F star are used to maintain the constant V by F ratio, which is controlled by the flux block flux, and after the V saturate above the base speed, the frequency can be changed using the FR signal. So this is the all about the variable frequency control of induction motor drive. Now the variable frequency and variable voltage supply, how we can obtain, and based on that the next scheme for speed control of induction motor drive is the voltage source inverter VSI control. As we have already studied the VSI voltage source inverter and CSI current source inverter in the previous semester in the power electronics. So we can use the VSI and CSI to control the speed of induction motor drive. The VSI is used to get the variable frequency and variable voltage supply for induction motor. So VSI induction motor drive. Now we have to study the VSI induction motor drive. The voltage source inverter allows variable frequency supply to be obtained from a DC supply. The VSI scheme is shown here. This is the a DC voltage VD. This is the voltage source inverter VSI scheme using the thyristor. There are 6 thyristors are there: T1, T2, T3, T4, T5 and T6, and the output of this VSI voltage source inverter is a stepped wave. So the frequency can be controlled using the controlling the VD. So the VSI scheme we have already discussed in the previous semester, so we have not to discuss in the detail. But VSI, this scheme which is shown here, VSI can be operated as a stepped wave inverter or a pulse width modulated inverter. There are two type of VSI scheme are there. One is a stepped wave inverter and other one is the pulse width modulated inverter. When operated as a stepped wave inverter, transistors are switched in the sequence of their number. As the number is T1 to T6, each transistor is switched for the time duration of T by 2, while Each thyristor is kept on for the duration of T by 2 and switch in the sequence of their number with a time difference of T by 6. The time difference between any two switches is T by 6, overlap period is T by 6, and the each thyristor is kept on for the T by 2 period, and the resultant waveform we have not go under the discussion of VSI. We have consider the voltage waveform, resultant waveform which we obtain using the VSI. This is the resultant waveform where the width is the VD. So when supply is DC, variable DC input voltage is obtained by connecting a chopper between DC supply and inverter. So this VD can be controlled by controlling the DC supply, and to controlling the DC supply we have required a variable DC supply. The variable DC supply, how can we get the variable DC? We can get the variable DC using a chopper between DC supply and inverter. So by using a chopper is a DC-DC converter which gets the constant DC voltage to be variable DC voltage. So if we insert a chopper in between the DC supply and inverter, then we get the variable DC voltage. While when there is a LC filter which is used to remove the harmonics, and when supply is AC, variable DC voltage is obtained by connecting a control rectifier. When we have to convert a constant DC to variable DC, we can use the chopper. But if I have to convert the AC supply to a DC variable DC supply, we have required a control rectifier. This is a control rectifier block, and this is third three phase AC. This rectifier converts the AC supply into the variable DC supply, which is given to the 6-step inverter or VSI block. A large electrolytic filter capacitor is connected in DC link to make inverter operation independent of rectifier or chopper to filter out the harmonics in DC link. So this is the in all the circuits there is a DC link where the LC filter is used to remove the harmonics. So the inverter output line and phase voltage are given by the Fourier series. If we can make the Fourier analysis, if we can make the Fourier analysis of the output waveform, this is the output waveform of VSI block. If we make the Fourier analysis of this waveform, then we can resolve this waveform into the different component of different components. So VAB, if this is the line voltage, VAB phase voltage, so VAB can be resolved as a 2 upon root 3 into VD sin omega t minus 1 upon 5 sin omega t minus 1 upon 7 sin omega t plus 1 upon 13 sin omega t and up to the higher component, while VAN phase line voltage is 2 upon pi VD sin omega t 1 plus 5 sin omega t 1 plus 7 sin omega t and a higher component. This is the fundamental component. This is fifth harmonic, seventh harmonic, 13th harmonic are present in VAB, while fifth harmonic, seventh harmonic and other component are present in the VAN. So RMS value of the fundamental phase voltage, if we have to calculate, if we consider only the fundamental component, then the RMS value is root 2 upon pi into VD. So main drawback of step wave inverter is the large harmonic of lower frequency in the output voltage. If we can see the harmonic analysis, the Fourier analysis, we can see that there is a large harmonic component, fifth harmonic or seventh harmonic component are present with the fundamental waveform. Because of low frequency harmonic, motor losses are increased. Motor develops pulsating torque due to fifth, seventh, and 11th harmonic. Harmonic content in the motor current increase at low speed. Machine saturate at light load at low speed due to the high V by F ratio. So this is also some of the disadvantage with the step wave inverter. So this step wave inverter, this drawback of step wave inverter can be overcome when when inverter is operated as a PWM inverter. So in the PWM inverter, this is the output waveform of the PWM inverter. The circuit and other things I have already discussed in and already studied in the previous semester. We have just considered the waveform of the PWM inverter. So this is the modulated waveform where of sinusoidal PWM inverter, output waveform of sinusoidal PWM inverter. So since output voltage can be controlled by the PWM modulation, no arrangement is required for the variation of input DC voltage, as inverter can be directly connected when supply is DC. Therefore, a direct diode rectifier through a diode rectifier when supply is AC. As we know that about the PWM pulse width modulation, so by controlling these pulses, number of pulses and with modulation of this modulation index of these pulses, we can control the level of DC voltage. So we have not controlled the or we have not varied the DC voltage. DC voltage can be controlled or varied by the modulation index of PWM inverter. So this inverter can be directly coupled, VD can be directly coupled to the PWM inverter, and if supply is AC, then we have to place a diode bridge to convert this AC supply into DC supply, and this DC supply can be directly coupled, directly given to the PWM inverter, which gives the variable frequency supply. So fundamental component of output voltage of PWM inverter with sinusoidal PWM is given by V is equal to M into VD upon 2 root 2, where M is the modulation index. So by controlling the modulation index M, the output voltage V can be controlled or can be varied. So by using the voltage source inverter VSI control, we can control the speed of induction motor drive. So this is all about the variable frequency control using the VSI block, VSI, and remaining portion of the speed control are fall as per the syllabus in the unit 4. So with this conclusion, we have concluded and complete the unit number 3 as per the syllabus. And in the next lecture, we have started with the unit 4. Thank you.